Everyone. So this video is about basically the cryptanalysis of DES, data encryption standard. So in the previous video we have already checked that how we can encrypt using a block cipher named data encryption standard, and how we can decrypt also. So decryption uses the same algorithm as encryption. The only thing is the encryption is used in reverse order. So for example, the subkeys K1, K2, K16 are applied in encryption. So in decryption these keys will be applied in reverse order, like K16, K15, K14 up to K1. So decryption and encryption is same. The only thing is decryption is reverse of encryption. So basically this video is about the cryptanalysis of DES, data encryption standard. So if we talk about the cryptanalysis of DES, first we have to check about the keys. So we know that there are the key bit is 56, keys of 56 bits of length. Key length is 56 bits. So there are 2 raised to the power 56 possible keys in data in DES. So there can be 2 raised to the power 56 possible keys, which is a very large number, and it nearly comes to 2 raised to the power 256 nearly comes to 7.2 into 10 raised to the power 16 keys. So this DES has a 4 weak keys. So 4 weak keys, all 4 weak keys are either we have all 0 0, or we have 1 1, or we have alternate sequence of 0 1 0 1. So these keys are known as, these are the 4 weak keys. Using these weak keys, the outcome of PC1 or permitted choice 1 in the DES key schedule leads to a round keys K1 to K16 being either all 0, all 1, or alternating sequence of 0 1 pattern. So these are the weak keys. So when we do the PC1 using these weak keys, we give the output of the pattern keys are either K1, K16, the sub keys are either they all becomes 0 0, or they all becomes 1, or they all give us alternating pattern of 0 and 1. So since all sub keys are identical, because if all sub keys are 0 0, it means all K1 to K16 all the keys are 0 0. So it means all the keys are identical, or they all are 1 1. It means all keys are identical. In case of alternating pattern of 0 1 also, the key will be identical. So we know that DES is a Feistel network. The encryption function becomes self-inverting. That is, encrypting twice with a key produces the original plain text. So it means we can write it like EKX is equal to X for all X. That is, the encryption and decryption are same. So we should avoid such type weak keys at the time of key generation. So this is one thing, that the DES have 4 weak keys, and these are the 4 weak keys. And why we should avoid these keys? Because they produces almost the same subkeys. So when they produces the same subkeys, it means when we use those subkeys into the Feistel network, the encryption functions becomes self-inverting. It means if we use that function twice, it gives us plain text, the same plain text. Besides these 4 weak keys, we have some semi-weak keys also. So there are 12 semi-weak keys. These are also, they produces 2 different subkeys. In place of 16 same keys, they produces 2 different subkeys. So it means they are producing 8 same keys. So we can refer to them as K1, K2. They have the property that EK1 and EK2X is X. These 2 subkeys, if they are inverse of each other. So there are 6 pairs of DES semi-weak keys. So note that weak and semi-weak keys are not considered fatal flaws of DES, because there are 2 raised to the power 56, almost this amount of possible keys of DES, out of which only 4 are weak and 12 are semi-weak keys. So it means they doesn't, like, this is a huge number. If you see, this is a huge number. So those 16 weak keys with weak and semi-weak keys does not cause a fatal flaws, but we should avoid generating such type of keys. So this is one thing about the keys. Next is the cryptanalysis of DES. We know that we can do cryptanalysis by 2 methods. First one is the brute force method, and the second one is we can analyze it with some other methods, some very well known factual methods. So first we will talk about that if this brute force method work on DES or not. So if we talk about brute force method, there are like known plain text attack. This is about known plain text attack. Known plain text attack means the cryptanalyst knows one or several pair of ciphertext and the corresponding plain text. So this is known plain text attack. We cryptanalysts already know the one or several pairs of ciphertext and corresponding plain text. So generally what we say that we know the plain text, we know everything is, we just only the key is secret. So it try 2 raised to the power 56 possible keys. So what is the challenge? A series of brute force attack contest created by security. The secret message is this. So first challenge is in 1997. Thousands of volunteers connected by internet solved it in 96 days. It is almost 3 months. Message was, the secret message is, many hands make light work. In 1998, EFF, Electronic Frontier Foundation, non-profit organization, but the machine break this cipher, but the machine cost $250,000. And in 1990, distributed.net or deep crack combined 22 hours and 15 minutes. Message was, see you in the room. So this is how it is broken. So what it is? A single computer, like, because we have 7, this is a huge number, 2 raised to the power 56 is equal to 7.2 into 10 raised to the power 16 keys. Need to check. So this seems that brute force attacks is impractical. So some estimate says that if a single computer performing 1 DES encryption per microsecond, it would require more than 1000 years to break DES. Another study says that a single PC with multi-core processor can perform 10 raised to the power 19 almost in 1 billion key combination per second. It needs 1.125 years. And another say a contemporary supercomputer that can do 10 raised to the power 13 encryption per second, it needs 1 hour to break DES. So it is a very costly, like whatever we have already, it has been broken, but it is a very costly procedure. So but DES has been, yes, it has been broken by these three analysis. So this is known as analytical attack, or like first one is known as dictionary attack. Each plain text may result into 2 raised to the power 64 different ciphertext, but there are only 2 raised to the power 56 possible different key values. So encrypt the known plain text with all possible keys. Keep a lookup on the table size 250, 2 raised to the power of 66. Given a plain text ciphertext pair, look up C in the table, but it will definitely take a lot of time. So these are the some analytical methods other than the brute force method. So analytical method, first one is differential cryptanalysis. Differential cryptanalysis required 2 raised to the power 47 XY pairs. It is a known plain text attack. 2 raised to the power 47 XY pairs means X is plain text and Y is cipher text. So if we know 2 raised to the power 47 XY pairs for same key K, for the same key K, practically it is very hard. But if we know this, then we can do this. Like this is chosen plain text asset. Assume that an attacker known plain text and ciphertext pairs. Differential cryptanalysis involve comparing XOR of 2 plain text to the XOR of 2 corresponding ciphertext. So distribution of delta C's and delta P's may reveal information about the key, certain key bits. After finding several bits, we can use brute force attack to find the complete key. So second one is linear. So this differential, surprisingly DES was resistant to differential cryptanalysis. At the time DES was designed, the author already knew about the differential cryptanalysis. S boxes were designed to resist differential cryptanalysis. Against 8 round DES, such as attack requires 2 raised to the power 38 known plain text ciphertext pair. A couple of minutes on a small PC. Against 16 round DES, attacker required 2 raised to the power 47 chosen plain text. So differential cryptanalysis is not effective against the DES in practice. Now let's talk about linear cryptanalysis. So another method is, instead of looking for isolated point at which a block cipher behaves like something simpler, it involves trying to create a simpler approximation of block cipher as a whole. It is an attack that can be applied to an iterated cipher. So linear cryptanalysis, 8 rounds, 2 raised to the power 21 known plain text should be there, 16 round, 2 raised to the power 43. So it reduces 40 days to generate the pairs and 10 days to find the key. The attack has no practical implication, requires too many pairs. So exhaustive search remains the most effective attack. Like we discussed, there are 2 raised to the power 56 keys. So exhaustive search known as 1 and 1 plain text, storage complexity is negligible, but the processing complexity is 2 raised to the power 55. Linear cryptanalysis, there should be known thing 2 raised to the power 48 or 38 text, storage complexity for text, and this is the processing complexity. Same is for differential cryptanalysis. So the weakest point of DES remains that size of the key is factorial 56 bits. So this can be breaked, and it has already been, the data encryption standard has already been broken, and now the block cipher which we generally use is known as AES or advanced encryption standard. Then we have some variation on DES also, which also we will be discussing in coming videos. So how we can improve the block ciphers? We can there should be a variable key length, mixed operator, use more than one arithmetic or boolean, this can provide non-linearity, data dependent rotations, key dependent S boxes. So we here in DES, what is the S boxes are fixed. So S box value is fixed, but it should be key dependent. So then the block cipher will be more complex. Lengthy key schedule algorithm, variable plain text ciphertext block length, variable number of rounds. So number of rounds are also fixed in DES. Operation on both data halves each round. Like first round, if you see that we don't do any operation on the left side, we do only on the right side. But it's said that if we want to improve upon the block cipher, the operation should be on both sides. Variable function f varies from round to round. So there should not be a fixed f function for every round, and key dependent rotation. So if we apply all these things, definitely we are going towards improving the cipher. Then there are two important things in cryptography. First one is avalanche effect. What avalanche effect means? Avalanche effect says that the avalanche effect is a term associated with a specific behavior of mathematical functions used for encryption. Avalanche effect is considered as one of the desirable property of an encryption algorithm. A slight change in either the key or the plain text should result in a significant change in the ciphertext. This property is termed as avalanche effect. So it means that if we make a slight change in the key, it's going to make a huge impact on the ciphertext. So the DES is having a strong avalanche effect. Like input is 0 0, this is function, output is this. But now when we make a slight change in the key, like now input is 0001, there will be a huge change in the output. This is called avalanche effect. Next one is completeness in cryptography. Completeness means each ciphertext bit should be dependent on one or more than one plain text bit. So if we talk about DES has high completeness effect because S box and P box. So avalanche effect and completeness effect both are high in DES. So this is about the cryptanalysis of DES. It cannot be broken by differential, it can be broken by differential and linear also, but then it's there is no meaning to, it is meaningless to break with these methods, because it is very hard and practically it is almost impossible. But if we talk about the brute force attack, because of the key is to 56 bit of length, so it means 2 raised to the power 56 we can generate, and it can be like using the exhaustive search, it can be broken, and it has already been broken in the 1998. It has already been broken. Deep crack special purpose DES hardware cracker, and it cost about 250,000 US dollar, although it is very costly, but it has been broken. So nowadays DES is not considered as a very effective block cipher. So generally for high security purpose we always use AES or advanced encryption standard. So in the next video we will be discussing about alternate of DES, that is known as triple DES. We will check about the encryption and decryption of triple DES, then we will move towards the advanced encryption standard. Thank you.